That good? Okay. All right, so welcome to this introductory course on Bob and Python with hands-on. We had quite some work to prepare this for you guys. We hope it's useful. So here are some motivational slides, so why we actually went into this direction in our group. Basically, we saw ourselves all the time constantly re-implementing things. And sometimes it would be quick, because we just needed something for a paper, and this would lead normally to very buggy code, or good quality, but then with a high cost. I mean, it would take a lot of time for us to implement things, okay? And it was not sure that basically those things that we took a lot of time to implement would stay around and be used by other people. So there was a lot of sharing of those good things, and also for the bad things, modifying, fixing bugs here and there, a lot of divergence, so people were doing things twice, 3 times. So it was very difficult to build highly complex systems and experiments with that working model. Okay, and of course, not to say that lots of code would basically just reach a dead end when the experts that were managing that code would leave, if the code was very complicated. So it was very difficult to reuse code that a person that left. So we ended up with papers and publications and everything, but the details on how we actually got to those results, or the code that explains, the thresholds and all the details that are often hidden in the paper, would be lost. The results were very difficult to reproduce, and we lost a lot of time trying to reinvent the wheel. So the initial motivations were basically to develop and share good quality code with our research group. Okay, so this started with that idea. And to have some baseline results that we could reproduce every time we published. So it should be easy to reproduce experiments. Okay, so that was the key idea on the development of this framework you're going to see today. It should be easy to write the algorithms that actually we run on the experiments, access the data, and when I say that, also in terms of which kinds of protocol should be used when I want to report this kind of error, which kind of metric should I use when I want to run this kind of experiment, and of course have documentation that will be maintained through the years and as people come and go. Of course, you get an extra thing on that because that affects your visibility. Okay, so basically this is a quite pictorial representation of the research cycle that we normally go through. We basically have idea, then we go and try to find data where we can test that great idea. Test a lot. Sometimes we go and improve that idea a little bit, continue testing, find more data and things like that. And if the idea works, we finally write a paper. Then after we do that paper, we can have another idea to extend the paper again, and then we continue on that cycle. Okay. So normally, what you get in the end of the cycle is basically just the paper, but what we wanted with Bob and the framework that we're going to present you is a little bit more. We wanted to cover all the areas here, so we basically get in the end what we call reproducible research. Okay, that's a way by which not only the paper is released when you finish that work, but also the data and the code that you use to actually get to those results are also available to other people to reproduce what you just did. And that affects your visibility because it increases the potential impact of what you're doing. Okay? And this is always good in the academic area. So the course, I will hand it over to Manuel now, is divided in 3 parts. The first part is an introduction to Python and NumPy. Actually, the NumPy part, I think we moved into part 2. The second part is going to be an introduction specifically to Bob. And the third part, I'm going to talk about advanced topics. So a bit on how to glue all that research cycle together and how to make your work public.